Dear friends, in this video we are going to discuss about 3-point starter. First of all, what is the necessity of starter to the DC motor? At starting, the speed of a DC motor is 0. When speed is 0, the flux cut is 0 and back EMF is 0. So when back EMF is 0, the armature current which is drawn by the motor IA is equals to V minus 0, means EB is equals to 0. V minus 0 by RA. So finally armature current is equals to V by RA at starting. If you take 8 kilowatts 250 volts motor which is having armature resistance 0.5 ohms, the rated current is equals to 8 kilowatt by 250 volts, we get 32 amps. So this is the rated current of this particular motor. And at starting, armature current IA is equals to V by RA. So now V 250 and armature resistance 0.5. So we get 500 amps. So at starting, the motor draws 500 amps instead of 32 amps, which is 15 times more than rated current. So to restrict this initial dangerous current at starting to the armature, we are arranging a series resistance which is also called starter. Okay, so now constructional details of 3-point starter. 3-point starter is used for DC shunt motor. Okay, coming to construction, L, F, A are the 3 points. L is the line, F is the field, and A is the armature. So we have 2 electromagnets. One electromagnet is connecting in series to the line, another electromagnet is connected in series to the field. And here we have handle. So this handle is having a soft iron piece. So I will tell you what is the purpose of soft iron. And when we move the handle to clockwise direction, it moves or it touches the all studs. Okay, and here we have number of studs. So here actually 6 studs. In between 2 studs we have some resistance, some section of resistance. Okay, so R1 is one section of resistance, so R2 another section of resistance, and so on. Okay, so this is the starting resistance which is connected in series to the armature. This is the no volt coil which is connected in series to the field, and this is the overload relays which is connected in series to the line. And here we have spring. When we move the handle in clockwise direction, the spring opposes the movement and it always tries to pull back the handle. Okay, so now coming to operation. When we give DC supply and close the DPST switch, so the current flows through the OLR, and at the handle is when at off position, so no current flows to the motor. When we move the handle stud by stud, the back EMF increases, the resistance decreases. Actually, when back EMF increases, the necessity of series resistance decreases. So that's why when stud by stud, when back EMF increases slowly and slowly, we are going to cut off the resistances in the same manner. Finally, at stud number 6, all resistance is cut off. At that time, the back EMF is rated value. When back EMF is rated value, no need to this series resistance or starter. Okay? So, in this way, we are going to decrease the initial dangerous armature current. Okay? And now, what is the purpose of overload release and no volt coil? So first, no volt coil. No volt coil is connected in series to the field. When we move the handle at run position, up to run position, at run position, the handle, the soft iron sets here in this gap. When it sets in this gap, the no volt coil or this electromagnet hold the handle. When it holds the handle, so the operation goes on. When supply failures, it releases the handle with the help of spring force. If the NVC remains the handle even though supply failure, what happens? When supply restores, the current directly enter to the armature and armature will burn or damage. Okay, that's why when supply failures, the NVC demagnetizes and it releases the handle and the handle comes back to off position. Okay, in this way the NVC, the purpose of NVC to hold the handle at the time of operation, and at the time of supply failure it releases the handle and saves the motor. Coming to overload release. The overload release, when current is up to rated value, so the operation is normal. When current is more than rated value, means overload. Overload means over current drawing. When motor draws more than rated current or over current, the electromagnet is having enough magnetism to pull the plunger upwards. So when the electromagnet pull the plunger upwards, so the coil short circuits. When this coil short circuits, NVC demagnetizes and again it releases the handle to back. In this way, the OLR and NVC helps the motor from dangerous position. Okay, and now the drawback of 3-point starter. Actually, when resistance varies, when resistance increases, the speed increases. So when resistance increases more and more, the field current through the field decreases. When IF decreases very low, what happens? So the same IF flows through the NVC. So here, when weak IFC or when very low field current flows through this electromagnet, the electromagnet demagnetizes and it releases the handle at the time of operation, so which is inconvenient to operation. Okay, so this is the drawback. So by arranging one more point, that is 4-point starter, by using 4-point starter we are going to rectify this problem. Okay, in next video we will discuss a 4-point starter. Okay, so bye.